Bienvenidos a nuestra presentación. Nuestro tema es comunicaciones industriales con los protocolos de Hart, Profibus, Modbus y Devicenet. Mi nombre es Juan Camilo Zapata Vélez y mi compañero es Mateo Galeano Pin.
Okay, before we begin talk about the industrial communication, we want to talk about these concepts that are very important to know the meaning of them. So the glossary begin with the first industrial communication. Industrial communication networks are the backbone of any automation system architecture, providing a powerful medium of data exchange, data controllability, and flexibility to connect multiple devices. Next, we have the network. A network is an interconnected group of computers and or controllers and devices that interact with computers and controllers. And the last but not least, the node. A node is a computer or other devices in a network. Networks are interconnected by different types of conversion devices, cables, and sometimes by radio transceivers.
Now, we move forward with a definition of industrial communication. Data communication refers to the transformation of information or data, mainly in digital format, from a transmitter to a receiver through a link that connects these two. Traditional industrial networks are used to allow data communication between computers and their peripherals and other devices. On the other hand, the industrial communication network is a special type of network made to handle real-time control and data integrity in harsh environments over large facilities. Industrial communication generally uses Ethernet, Devicenet, Modbus, ControlNet, but other protocols such as Hart and Profibus can also be found.
Then we have the hardware and connecting cables. Communication and control protocols operating on a network need hardware devices and connecting cables to work. Some common hardware devices are built into computers and controllers or attached directly to them. Some examples of these connectors are uh, first, switches. Switches provide connectivity for many computers on a network and connectivity to other network devices, including other switches. Switches commonly have as few as 4 and as many as 48 ports for Ethernet cable. Switches usually have at least one port for and cable to connect to another switch or a router. Switches are usual but not always managed devices that is configurable by the end user. In Ethernet networks, they reduce chance that data collision will happen if simultaneous data transmissions occur. 5 second fiber optic cables. Fiber optic cable is used to transmit data over much longer distance than copper Ethernet cable. It can carry a great amount of data. Fiber optic cables are either single mode or multi-mode, and different type of cables pass light at different wavelengths. Individual fiber have very small diameters, and the ends of fiber optic cables must be prepared by a specialist before and connectors. There are about 6 common types are applied. They are available as either drawn long cables or patch short cables. Patch cables come with an connector applied.
Continue with the next topic, we have the network topology or arrangement. The first topology is the bus. The bus topology is the simplest. The presence of resistors at the end of the bus. Each node is exposed to data traffic on the bus, but it will only respond if data is connected to it. Otherwise, the data is ignored. A bus topology has the disadvantage that failure of the bus cable will stop communication, and resistors with identical resistance are used to improve signal quality on the bus. The next topology is the star. In a star topology, individual nodes are connected to a central node. Very often, the central node is a switch. Switches allow temporary pathways to be made so any node on the network can communicate with another node. In a star topology, an individual node can be disconnected without affecting communication of the rest of the network. It's more reliable than a bus topology. All data traffic stops if the central node fails. However, switches are built from high reliability, and often unbroken power supplies are connected to provide temporary backup power in event of loss of line power. Sometimes redundant switches are used to improve reliability. In that case, each node has two ports, with separate cables attached to each distributed node. And the last topology is the ring. The ring doesn't have a master device. Each node can both send and transmit data. Data sent from one node to another is forwarded around the ring from the original node to the destination node to which it is addressed. If if a segment fails, data can be sent in the reverse direction.
Okay, we now give way to the protocols of industrial communication, starting with the Hart protocol. Hart transmitter plays away atop the 4 or 2 milliampere signal that is not needed or sensed by a controller and doesn't affect the output of the transmitter. The wave's frequency is continuously varied depending on whether a bit is 0 or 1. The wave contains data about the circuit measurement and transmitter when when a hard handheld terminal is connected to the 4 or 20 milliampere circuit with a hard compatible transmitter. The user can monitor the circuit and adjust key transmitter aspect from the terminal. This simplifies the task of checking for problems and checking a transmitter range without remove the transmitter cover. The superposed wave is immune to electric noise and ground loop current, which can affect a purely analog 4 or 20 milliampere signal.
Now we have the protocol of Profibus. It is one of the best known and widely implemented open field networks. These networks are mainly used in the field of process automation and factory automation. It is divided into two protocols, Profibus PA and Profibus DP. The Profibus IP is a Profibus standard that applies to field devices and bus cables. It is interoperable with Profibus DP. Its rated communication speed is 31.25 kilobytes per second. Some of its characteristics are implemented with either twisted pair or fiber optic cable. If twisted pair cables are used, end-of-the-line resistors are required. Star, bus, and ring topology is possible when fiber optic cable is used. Connectivity to Profibus DP controllers is possible. Can support file devices using environments where explosion hard exists. 126 nodes can exist on a network when hubs and repeaters are used. Profibus DP is another Profibus standard which applies to controllers. Profibus DP is marketed for PLC application. Some of its features include it supports cyclic deterministic communication, 126 network nodes supported can optionally be configured with redundant cabling.
The next protocol is Modbus. It is one of the earliest control protocols ever developed. Data transmission in Modbus is serial. One bit follows another. In 2004, Modbus became an open protocol managed by the Modbus Foundation. Modbus is a relatively simple protocol that uses numbering schemes that are familiar to those who have programmed Modicon PLCs. Some commercially available instruments, meters, indicators, and actuators are Modbus compatible. It is correct to refer to Modbus as a control protocol, but it also can be used for data communication applications that don't require control capability. Many commercially available transmitters and indicators are Modbus compatible.
To finish this topic, we are going to talk about the protocol of Devicenet. It is an open device level network based on CAN technology. It is designed to interface field level devices, such as sensors, switches, barcode readers, and panel displays, with higher level controllers such as PLC, with a unique adaptation of the basic CAN protocol. It can support up to 64 nodes and 2048 devices in total. It reduces the cost of network by integrating all the devices in a 4-wire cable that carries both data and power conductors. Network power allows devices to be powered directly from the network, thereby reducing physical connection points. This network is popularly used in the automobile and semiconductor industries. To finish, we will give way to the questions that were made based on the previous presentation. Las preguntas son, primero, ¿qué es la comunicación industrial? Segundo, ¿qué tipo de cable es el de la imagen 2? ¿Cuáles son las topologías o arreglos de redes? 4. ¿Qué protocolo tiene este comportamiento, el de la figura 4? ¿Qué representan los colores en el cable del protocolo Devicenet?
Ok, para la respuesta de las preguntas, entonces, para la primera es, ¿qué es comunicación industrial? Entonces, son métodos para intercambio de información para elaborar un producto final. La segunda pregunta era, ¿qué tipo de cables es el de la imagen? El de la imagen es fibra óptica. Tercero, ¿cuáles son las topologías o arreglos de redes? Estas son las topologías, bus, estrella, anillo. Cuarta, ¿qué protocolo tiene este comportamiento? El Hart de la figura anterior. Y quinta, ¿qué representa los colores en el cable del protocolo Devicenet? Representa datos y poder.
Gracias.
Muchas gracias.